All right, let's go ahead and get started. This is part 3 of 3. You'll finally be rid of me after this. The trilogy is complete. We spent parts 1 and 2 going over a lot of the front end and with Angular and everything else. Mostly the focus was on Angular because that's the newest part of the stack. But if you need to, we have the videos and the slides. Again, if you just change your URL, there's part 2, part 1. You're welcome to go back through the slides. Part 1, unfortunately, we didn't get it recorded, but you can still go through the slides. But the good thing is in part 2, we actually went back and reviewed part 1 very quickly. We kind of did a high-level overview, and then you obviously have the slides as well to follow along. So we're in part 3. We are finally done with the front end. We're going to go on. We're going to go full-blown on the server side. We're going to be in .NET Core 2.2. And we'll talk about a lot of concepts that aren't necessarily directly related to .NET Core, so that Java and some of these other practices, you'll get hopefully some benefit out of some generalized discussion on back-end concepts as well. But the bottom line is we are at the end. So thank you so much for all your participation and support from the previous 2 sessions. And let's get going because we got a lot to talk about today. So topic number 1, Web API design. We hit on this just at the very end last time. We tried to get to the back end last time, but we unfortunately ran out of time. In terms of this maturity model, in terms of how mature is your API design, how RESTful is it? The concept of REST, there's dogmatic and there's pragmatic approaches, and you kind of got to balance the two. There are the purists that say it has to be this way or it's inferior, and there are other people that say whatever works, works. And so let's try to find a happy medium in there. Back in the day, we had old XML or POX swamp, as you know, with WCF and some of these other ways of doing things with SOAP. When we go to a REST-based model, we have a single URI endpoint. Level 1, which sometimes people still do, you have multiple URIs, and you've got the verbs that go on it. So your URL, sometimes you'll actually have like get or post or whatever in that URL. And that's okay, but we want to bump things up and make it a little more RESTful in a truly stateless way and take advantage of HTTP and what it offers us. So we have level 2, which is same URI, same endpoint, but we have different verbs that operate against that endpoint. Get, post, put, delete. We'll talk about that in a moment. And then if you're really focused and want to be super cool, and especially in the case of public-facing APIs, you really want stuff to be self-documenting and all the stuff we're going to talk about, there's level 3. Which is, it's a terrible acronym, HATOS. Basically, it stands for Hypertext as the Engine of Application State. And that basically means you have a starting point, and you basically have graphed out your entire Web API, your endpoints, and you can navigate using hyperlinks to go from one place to another and kind of basically make your way around the application. So, in terms of RESTful constraints, these are, the REST API Design Handbook is it's a short read. We did it in our book club a couple months ago at STG. Talk about this concept of, these are some constraints that in my opinion make a RESTful web API very good. First off, we're able to evolve independently. You've got to decouple your resource model from the underlying implementation. A lot of people, when they want to get something up and running quick, they have their underlying classes, their data models, whatever, and it's database level, and they'll return that straight up through the API. We want to be able to separate the two so that when back-end makes changes, front-end doesn't break. You can evolve both at the same time. Number 2, stateless. We want our web API endpoints. We don't want to be able to have to worry about state. There's no concept of session on the server. When an HTTP request comes in, it doesn't know anything about the previous request, and that's by design. We do have some caching options as well. You don't have to do that, but if you feel for resource-intensive things. Number 4, uniform interface. This is the biggest part. So resource-based versus service-based. So we have this URI, but whether you're returning JSON or XML or whatever you want, we're going to have so that the client negotiates what you get from that API, what data format. And that's all via the accept header. So we want to design our API to be kind of agnostic to the data type. We will support certain things and not support others, but you want to be clear, hey, if you want XML, if you want JSON, whatever your needs are, especially for public-facing URIs and legacy apps that use XML, it's nice to have that option that the client, not the server, negotiates the type. HTTP verb-based. Again, we're operating on the endpoint, but the verb is determined by the HTTP side of things. It is not actually in the URL, for example. And then this third one on here, discoverable, self-documenting with predictive results. This is huge, especially for public-facing APIs. You want stuff that makes sense. The URLs are pretty easy to navigate through. We'll talk about that a little bit more. And then if you find yourself having to redefine verbs, you know, I want to do kind of something like a post or kind of like a put or a patch, but I want to make it my own, or you're trying to tweak with these status codes and saying we want our own custom status code that we return. You can do that, but it breaks REST, and it's usually not very clear what your intent is for a consuming application. And then number 5, layered system. So all your versioning, your load balancing, your redirection, your proxies, all that stuff needs to be hidden from the consumer, and it needs to be abstracted away. So again, this talking more about these HTTP verbs. We have the concept of a get and a post. When we do a get, we want a read-only way of getting our data. We don't want any side effects. There are exceptions to this. I think of logging as one of the most common side effects that's okay if you just want to do some side logging. But as long as that doesn't break the call, you know, if some logging system fails or something like that, you still want the get to succeed. Post is usually reserved for creating a new resource. When you do a post request, the idea is you are inserting into the database. And this is where things get iffy. With put, the idea is you're updating an existing resource where you pass in the entire object that you're updating. It is all or nothing. So for our purposes, though, and what I found in my experience, I tend to use a put for all update operations as opposed to a patch, when you see on number 4 there, for updating an existing resource, but you have to specify which fields are to be updated. So you just want to go in there and tweak a field. You would do that as a patch. Again, I haven't seen a whole lot of implementations of this, but when I do, when you have to use a JSON patch document type and all this stuff, it gets kind of messy to manage. So what I like to do in mine, in terms of balancing pragmatic versus dogmatic, I'll go ahead and do a put, but I'll just pass the object containing the fields I want to update. And if a property on that field is null, it gets set to null in the database. So it's pretty clear cut. The object that you're sending in is how it gets updated. So again, there are lots of different ways to do this, but we're trying to be pragmatic about it. Delete, obviously self-explanatory, you're deleting the resource. Again, in terms of being idempotent, I think is the term, where you do the same thing multiple times, you get the same result. Delete's obviously a different scenario. And then options, you'll see when you do your Angular service calls to the server, you'll see 2. It looks like you hit the server twice, and technically you did, but usually you'll see that first is called a pre-flight request. And what happens is Angular goes in and it just pings the server to see what can I do, what verbs are available on this. It's just kind of a way of getting information about an endpoint without actually doing the get, post, or whatever it is. So usually do those in conjunction. Status codes, these are pretty self-explanatory, and I'm sure you've all experienced your 500s and your 400s. Just make sure we use them where it makes sense, where it's semantic. We don't want to serve up a 500 if it's some client validation error, for example. So I'll let you guys go through these later because we got so much to get through, but the idea is use the status codes as you would expect. We have redirection for 300s, 400 for client errors. There is kind of this debate of what do we return when it's a client-side validation error that actually doesn't get caught on the client, because as you know, JavaScript's weird and sometimes stuff just doesn't get caught. You want to catch it on the server. What do you return if it's a server-side error but it's client-side validation that should have caught it? I like to do a 400 in those kind of cases. Some other people might disagree, might want to do even a 500 because something went wrong on the client, but the server was the one that failed trying to validate. So again, it all depends on your application's needs and what makes sense to the consumer. 500, self-explanatory. You guys get those all the time, I'm sure. Again, there are so many status codes in the spec, and I've outlined the only ones that I've ever used. You really don't need to use all of them. It gets too complicated and too convoluted to try to make sense of someone's API if they have been very granular on their status codes. But for a more advanced API, maybe it makes sense to use all of those. What do you return when everything's okay? Do you return an object? Do you return just a 204, which is, yes, everything went well, but you don't need to know anything else. So in general, I like to return a 200 with a get, with an object. With a post, you return a 201 saying, hey, this was created, and then maybe in the header, and your, I forget the actual header value, you say, here's the link to the new object. But just be consistent. I mean, that's what it all comes down to with your API and designing it. This comes down to a controversial, not controversial, but lots of different ways of handling it. So you're telling me I want to do a GET request. The thing with the GET request is that the values are not in the body. The values of a GET request are in the URL itself. So you have the question mark, and then this equals this, this equals this, this equals this. But that kind of breaks down when we're talking about sensitive data in the query string, right? If you have a search form and you're typing in someone's SSN, and you do a GET request, that SSN in plain text is going to be in the URL, and you're like, well, what if it's HTTPS? Doesn't matter, because a user can bookmark in a URL, and guess what? A URL is going to have all those query strings in there. So what do you do when it comes to sensitive data on those GET requests? Well, you can break the rules and do a post, or a put, depending on what you're doing. It's okay sometimes to use a post to get data, because in a post, as you probably know, everything's in the body of the request. So that is masked. You can't bookmark a post, right? Another version, and this is what Google and a lot of the big companies do, is the second option. You encode the data somehow. You see your Google Doc, and you have this big, long, ugly string in the URL. Most likely, they're doing some sort of encoding of that data so that you're not exposing that sensitive data in the query string. But obviously, with encoding, encryption, you've got to have a strategy up front to handle that. So I thought I'd bring that up. In terms of a web API implementation, not a whole lot I wanted to go over because I wanted to go more of the concepts, but Swagger is a really cool tool that I like to use. Swagger and OpenAPI are kind of used interchangeably, and they basically are, but what Swagger gives you is it is the set of open source tools that's built to the OpenAPI spec. And what's nice is Swashbuckle, which there is a .NET Core implementation of, can auto-generate that spec file, which is JSON or YAML, whatever you prefer. And basically, that gives you a standardized way to document your API dynamically. So you're going in, you're adding controllers, you're adding methods, you're adding all that, and Swagger is taking care of that. Swashbuckle, rather, is taking care of keeping that spec up to date and keeping your documentation in sync with your code. So great thing about Swagger is you don't have to clutter your code too much to get an API documented and up and running. But the disadvantage is that can also be a disadvantage, because as soon as you want to go more custom with your documentation and more details, you find yourself having to add things to your controller methods, metadata, comments. You have to format your comments in a certain way for Swashbuckle, for Swagger to understand it. And so cluttering your code for the sake of a tool is generally a bad idea if it becomes unwieldy, right? Most of the time, Swashbuckle and Swagger, it's pretty straightforward. You don't have to do a lot of cluttering of your code to get it to document. But there's a great Pluralsight course that goes into a huge amount of detail on how to do it down there at the bottom there if you need that link. Oh, cool. Something just failed while we were... That's awesome. Okay. So in terms of Swagger setup, it's super easy. You got your startup CS. We'll talk briefly about the startup CS in .NET Core. It's just a few lines of code. You just say, here's my Swagger doc, and here's my endpoint. And this brings us to the concept of middleware we'll talk about a little bit with .NET Core. Basically, you add your service to the service collection, whether it be your own or a third party. In this case, it's Swagger. So services.add Swagger there on line 1. And then you use it in your startup CS. You say, okay, I've added it to my service collection. Here's how I want to configure it. So this bottom part in the startup CS says, here's how it applies to the HTTP request pipeline. So as a request is coming through, we'll talk about this a little bit more shortly, but the idea is that now you can throw that into your HTTP request pipeline and pass it off to the next part of the life cycle. I was going to actually go and show the site, but for now, just for sake of time, probably let's see. Yeah. If I go and let's see if we can just log into the production site. And again, this is in production. If you have an STG Gmail address, you can get in and start looking at this, sttprofiles.azurewebsites.net. You will get booted if your account is not an STT domain. And if you still get in, then you can submit a bug request to me. I hope you can. Let's see. So if I hit the API here, and you notice, back what I was talking about before, it looks like you hit your API twice, but usually with Angular and how HTTP works, it's going to do that pre-flight request. You see the request here as an options, and then we actually do the get request here. So if I open this guy up, I'm not going to be able to get in because it's 401, right? I can't just go and get a URL because I have authorization on here. I'll show you that in a second. But the idea is I can at least get to the endpoint. And the endpoint, for most, you can configure this, but is just Swagger, right? So you go to and your API now is documented. I didn't have to add, basically, other than that startup code that I showed you, I didn't have to add hardly anything. And now I've got a nice kind of Swagger UI generated tool that will show me all my different methods. And I can drill into one of these, like if I want to say, okay, I want to get profiles. What are the parameters that I could pass? Are there some default values? What am I expecting back in terms of a response? What kind of codes can I return? You may find yourself, everything's a 200, everything's it's not as specific. So what you may find yourself having to do, and I'll show you here in the groups controller. I think I put it in there. Yeah. You may find yourself having to say, okay, well, I want to make sure that I am returning certain response types. I want to make sure all my bases are covered of the combination of things that can go wrong. And you see my commented out code here on line 32, 33, 34. You can say, okay, I want to return a 404. I want to make sure I return an OK, a default response type for empty stuff. And I say up here, if you want to not have to do that to every single method in your controller, you can just say, hey, just give me the default API conventions. We assume that this can have a 404. We assume, and they'll make some assumptions based off of your stuff there. So you have some things that you can fine tune with minimal code overhead in order to get that working right. Okay, so let's go back here. I really need to look at that error. It's just like randomly failing. Okay. HateOAS. All right. Let's launch. I think we have a minute here. Locally, I want to see. Here we are. That's probably why it was failing. So I'm going to run the app locally here, and we'll show you some techniques to running your API, your authorization server, and your Angular app all at the same time with Visual Studio. It's pretty sweet. But I want to go to the API. So if I go, I usually just look at a network request here because I can never remember the URL. But if I go to this guy here, I want to talk about HateOS for a minute and how that works. So if I go to /API, so this is the concept. The concept is I go to the root of my API and I get an array of objects that document the API, right? So now from here, from the root of the application, here's where I can go and here are my options. So I want to say, okay, well I want to drill into profiles. So I actually did the request through the API, and I like to standardize what I'm returning from the API. So instead of just returning an array of results, I'd like to know a little bit more about the results. So I have some metadata here in a return object collection that says, okay, for paging and all that, here's your total result count when you hit the endpoint, other things for paging that you may need. And what's nice is, if I want to say, okay, well, what about related data? Profiles are associated with so many other things in the app. We did a demo of the site last time. You can look at that to get back on the speed of how the app kind of works together from a business domain perspective. But the idea is you have profiles that have social media links, groups, contracts, all that kind of stuff. There's a lot of different ways to do related data. I could do API/profile/ and then whatever that related entity is. But what's nice is sometimes I want to be able to be more dynamic and say I want to include these related objects. And that way the query that gets generated behind the scenes will do those joins, it'll eagerly load the data, and it'll be ready to go. So I could do an include all to just give me everything, or I can pick and choose what I want to include. But the bottom line is this is documented. I don't have to go and ask the back-end guy, hey, I need to get this and this. How do I do it? Say, hey, well, you have your links right here. You can start navigating. So let's say I want to drill down, and you have some samples here of how paging is. So if I go down to a particular, you notice right here, how do I get the next page of data? You have link types that will tell you, hey, this is the next page, or a previous if you have it. So I want to go to page 2. So now I can navigate and say, if you look down, it's not on this one actually, I think it's on the groups. But you'll have previous and next links for your pager, so you can just reference the URL directly without having to construct it on the client. So if I want to drill down to someone, again, the metadata is always going to be the same. So it's, again, you're streamlining what you're returning from the API. And then you can say, okay, now I'm on this person. What can I get? I can get their social media. I can get their groups. I can get what skills they have. Again, this is, in my opinion, a fairly straightforward consumable API with those hyperlinks, with that HeyOAS. The disadvantage of this is it's very hard to maintain. This is a very manual thing that I've done to do this. Swagger does this concept of links that can kind of do this, but if you want to customize it, it's a little more difficult to do. So just so you know that that's out there, that's an option you have for kind of going the extra mile and really documenting your API. And when it comes down to those public-facing APIs, it becomes really important. Okay. We don't have time to talk about a lot of these other API concerns because we've got so much more to get to, but return types, I briefly touched on that. Standardize what you're returning so that people, consumers of your API, can expect, hey, these are the properties. No matter what endpoint I hit, I got some form of consistency. Page data, we don't have time to talk about that, but there's lots of different strategies for paging your data. Handling validation, I did want to go over that really quick. Validating, always you want to do client-side validation, and then you want to run it again on the server because who knows what the client's going to miss, right? And you want to make sure that the data entering your system is valid and that the values are valid regardless of what happened on the client. So we have this extra check that we do. Well, it's kind of a pain in the butt because right now you can go in and say, if model state.is valid or is invalid, then throw a 400 or whatever. That seems very repetitive. I want a global way of doing server-side validation. So what's nice is I can go in and do this through what's called middleware in my .NET Core application. So in my startup class, I have global, a place where you can put all your global filters. They're called filters, or middleware is the more generic term. They're kind of the same. So what you have is, I am on the wrong startup. This looks like the right one. So I have, let's see where I put them here. Right here. So when you're doing your service injection, almost always you're going to do add MVC because you want that convention of how it responds to those HTTP requests, how it figures out which method to call on the server. But then you can pass it this config stuff. We'll talk about authorization and policy-based authorization shortly. But let's look at line 84 here. We have this, sorry, it's a little, is it going to let me zoom in here? Maybe not. Move this guy out of the way. Come on. There we go. That's a little too big. Okay. So on line 84, for example, we are adding a global filter. So every request through our system, everything runs through this. And so you want to make sure performance-wise that it's near instantaneous, just because you know that it is very much global. But what we can do, I can show you this guy here, if it will let me. Fine, I'll just go to it. Model attribute, there we go. Keep your global stuff as simple and as performant as possible, and this does my check. You have access to the entire request, your context, everything you need to know about that request or response, whatever it is. You have all of that in your filters. So you say, okay, you inherit from action filter attribute, and it just has that one method that you override on action executing. and you can say, okay, is my model state, is it valid or not? If not, go ahead and throw, or you just set it to a new result. A lot of these request types are built-in types, so you don't have to new up an HTTP status code or anything like that. And you just pass in the model state, and you'll get your list of errors in a nice string array format from the server each time this happens. Now, what you notice is this context.result. Middleware can be set to terminate and say, okay, we're done. If there's an exception or if there's something that happens, I don't want to process any more, any part of that HTTP pipeline that I've configured through my middleware. I want to just stop the process. You can do that. But in this case, we're going to set the result, but we're going to let the rest of those middleware components still handle it down the pipeline. So you have this architecture that you kind of have to set up of, okay, when a request comes in, it's running through these different, I can show you the different parts of the pipeline here. Yeah, so all of these are part of the pipeline. So anything in your configure method of your startup CS class is the pipeline. And so it will go in order. That's very important to remember. So if you're throwing an exception and your handler's after, sorry, you're out of luck. So you got to make sure, like authentication and stuff like that, you generally want to bump up a little earlier in the process. And with authentication, you can immediately exit something isn't right. They're not authorized or authenticated in this case. And then again, you have all of your pipeline in order. This will run on every single HTTP request. So what's nice about .NET Core is you have that flexibility to say, I'm going to build everything from the ground up, and I'm only going to take what I need, and I'm going to customize my pipeline for the needs of my application, which is a very powerful thing that's a little more difficult to achieve in the current framework. You have to do HTTP modules or HTTP handlers to deal with that kind of stuff, and it's a little more clunky. Okay, so we talked a lot about .NET Core, so I'll hit on this briefly. We're almost halfway through here, and we got a couple more topics to go over. .NET Core, it's cross-platform, it's open source, which is huge for Microsoft. I mean, granted, we've been this way for a few years now, but I can't stress that enough. Because of that, it is very much a flexible deployment. You can deploy to Linux, Unix, Windows, whatever. And it's also optimized for cloud if you want to deploy your application to Azure. .NET Core makes that very easy. It's also modular. Again, it's very, very bare bones. It's been rebuilt from the ground up. And because it's been rebuilt from the ground up, that makes things more efficient. Anything in your system.web namespace that you've been used to doing, all of those web forms and standard MVC, not your API controller, all these different things that were kind of causing the software to blow up previously with the full versions of the framework are gone. Your request sizes are much smaller, so it's much more performant. In fact, a factor of probably tenfold plus in terms of, because of the fact that those HTTP request sizes are so much smaller now. And as is tradition with Microsoft, they're going to confuse the heck out of you with versioning, because .NET Core, if you recall back in the day, used to be labeled as .NET 5 or vNext. They kind of had these different versions that they were going through for marketing. They're going to drop the core title. So from 2020 and beyond, .NET Core is no longer going to be called .NET Core. It's going to be .NET 5. And then on a regular cycle, I think every year, does that sound right for those of you who are following the release cycles? I think every year they're going to target a new major release. So it's going to be 6 in 2021, 7 in 2022. Don't quote me on that, but the bottom line is they're going to be more regularly scheduled, more of a semantic versioning type of approach. And then it targets the .NET standard, and that's important to realize. So when we talk about .NET, it's huge. We're talking about 3 different flavors, I guess you could call it. We have Mono, which is for your cross-platform mobile development. So when you're using tools like Xamarin, you're essentially Mono is under the hood for iOS, your macOS, your Android, to target those different operating, platforms. Then in the middle here, you have .NET Core, which is what we're using, right? And then you have the full .NET framework. All of these can kind of be summarized as some form of implementation of the .NET Standard Library. The .NET Standard Library is just a contract. It's a set of interfaces, a set of APIs that you say, I'm going to target this version, and that way I can have more compatibility between these 3 different environments. And if you look at kind of the latest news and developments and things like this, this is eventually going to be kind of merged into one .NET framework to rule them all type of thing. But for now, the targeting of the .NET Standard Library, whenever you have a new class library, rather than portable class libraries, which is what we were using previously, and before that with DLL hell and everything else that would happen behind the scenes, this is a good evolution in terms of being able to be a little more easy. It's a little easier to consume. If you target your class libraries to a .NET Standard wherever possible, that means if you need to switch platforms or switch targets, it's much more standardized and easier to upgrade. So this kind of illustrates the concept. The higher the version, the more APIs that you have available to you, right? Because they're working to implement more APIs as the .NET Standard versions go up. The lower version means you have more platforms that you can target. So what we do, if you want to maximize compatibility, you can see from the chart, you're going to want to target the lowest version that you can as your goal. If you want to be bleeding edge and you only care about a web app or whatever, you're not as interested in that cross-compatibility, and for purposes of upgrading and staying on the latest and greatest, you want to target something a little higher. This is a little dated. There are more versions after this, but target something like 2.2 or whatever. And the idea is that Microsoft, everything's going to be on the same board and upgrade at the same time. The best thing about .NET Core from the standard framework that we've grown to love is CSproj. If you're familiar with the CSproj files, you probably had a merge conflict as soon as someone checks in their code, you add a new file, you have this big giant CSproj with everything explicitly having to be included in there. That's all gone away with .NET Core. The file structure is the project structure. I know this is a revolutionary new concept. Not really. It's been around from before, but they finally embraced it full force. But the bottom line is this, intuitively, it's common sense, right? But for reasons with MS Build targets and everything else, they had to do it the other way before. So now with .NET Core, we've released ourselves from all that, and we're saying, okay, the file structure matches the project structure, which means we don't have to put all of our stuff in the CSproj anymore. This is an example of a CSproj file from one of my projects. That's the entire CSproj file. You just give it a target framework. You may have a couple of other references to other projects and a couple of other things, but the bottom line is it's much more bare bones and easier to manage. Another nice thing about .NET Core is you're bringing your own editor. We're not coupling to Visual Studio anymore. Whatever editor you want to use. We are no longer coupling to IIS. IIS is a Windows thing, right? We want to be cross-platform. We want to be agnostic. You can set up your own, whether it be Kestrel or Kubernetes, whatever solution you have for your hosting needs, in the cloud or not, or on-prem. We don't care. We are not coupling you to IIS. And the main reason the main way that kind of gets pulled off is the fact that the .NET framework itself is a NuGet package, if you think of it that way. It is a dependency. The entire framework itself is a dependency, which means you can containerize it with Docker or whatever you need to do and have it be consistent. So yeah, .NET Core really embraces NuGet packages down to the framework itself, as opposed to sort of the second-class citizen that NuGet package management was before. We have some great templates in .NET Core for building SPA apps, and if you're starting a brand new SPA app like Angular, single-page application from like Angular or React, go through the templates that .NET Core provides if you know up front that your server-side technology is going to be .NET Core. The reason for this, I'll show you in a minute, it kind of simplifies your development flow because it's easier, it's integrated much more. Rather than having to do your ng-serve in another command window or a terminal or whatever, it's all integrated in Visual Studio. This next one is huge, built-in dependency injection. Built-in dependency injection should have been from the beginning, but we finally got it right with test-driven development and everything else. Test-driven development kind of spurred a lot of these needs for dependency injection. They weren't a thing back in the day. Now they're a first-class citizen. I believe under the hood it's a kind of a simplified form of Unity if you've used that as your IOC tool. But the bottom line is we can map our interfaces to our concrete classes in one line of code with no external dependencies, which is really slick. It's also bare bones, like we were saying. You have to explicitly say, this is what I need in my middleware. So we talked a lot about middleware, so I can skip a lot of this stuff. The basic thing is you're controlling your HTTP request pipeline and how things are coming in, how things are processed. It's all done in that configure method at the startup class. So, have just a little bit of time here. One thing that I got hung up on, and it took me a minute to figure out. So I create a brand new project, right? And I'm going to talk about these layers in just a moment, but the idea is I have my data layer. Think of this as your database layer, entity framework. This is the closest project to your actual database. Then you have the domain, which encompasses your business logic, right? And you're going to separate that. We'll talk about domain-centric in a minute. You're going to separate that so that everything feeds into this domain layer, not the other way around. Domain's going to be a whole bunch of interfaces. And then we have your Spot app, which is the Angular client-side project. And then we have our web API. I'd like to separate the two because your client, maybe you want to switch to React or some other implementation some other day, but I want my web API to be standard and self-contained and portable. So we have the web API as a separate project. And we have our identity server for authorization. We'll talk about that briefly in a moment. But the idea is, so I'm running my authorization locally. I'm running my Angular web app in Visual Studio. I want to at least. And I need my web API to respond to requests. I want to be able to debug on the server side as I would as a back-end developer. But as a front-end developer, I want to be able to do my thing where I'm in my TypeScript files and I'm making changes and it's automatically refreshing. It's done all that awesome stuff that Node provides and that NG provides with CLI and all that. I want to be able to have the best of both worlds in my development because I want to be full stack. So the way to achieve that that I've found, I mean, there's lots of different ways to do this, is we have this thing in properties called launch settings. And what launch settings does is it gives you these different profiles when you want to run the app. And we can say, okay, we have a lot of properties that we can set in this. They're just JSON. All the config stuff now, web config's gone away. It's all JSON now. So no more XML config. So with the launch settings, we have like launch browser. Do I actually want to associate when I run this? Do I want to actually launch a browser? And for everything but my Spot app, at this point, I don't care. I don't care. I don't need a separate window for my web API, a separate window for my authorization server. I just want just the Angular app to run in the browser or to show in the browser. And then I can hardcode. I say this is my application URL, and I can refer to that. So rather than saying Visual Studio or whatever system you're using picks my port, I want to be able to say this is my port. And that's important because when you go to do your authorization and stuff like that, you want to be able to point it to an endpoint of saying this is my app, this is the endpoint for my app, this is the endpoint for my web API. That needs to be hard-coded when it comes to localhost, or else you're going to run into lots of problems trying to get everything to talk to each other, right? So in every one of these, I have a launch settings that does things a little bit differently. So for example, in my web API, when I go to launch that, I have, let's see here, like this guy here, for example. Again, we have the same kind of stuff, but now slightly different things. Here's my endpoint for my application for the web API project, and then the Spot is the one that I actually want to run in the browser. So you see here, I have my profile here of this is the name that will show up here when I'm running it. If I were to run just this application, your command name here, and then you say I want to launch in the browser or not, and there's my endpoint there. So, but you notice up here, I'm running multiple startup projects. And the way we do that is over here we have, you can say rather than just running one thing, I want to be able to run multiple servers at once, or in this case my authorization server and my web API, and then I also want to run my Angular app. So I'm going to go ahead and start those, and I want to debug. I want to be able to step through things. I want the experience, the debugging experience as a back-end developer that I have. But then on the authorization, I just want it to kind of run silently in the background and respond to requests. And you'll get prompts for each of these, so it's not like you're not going to know what's going on in the server. But you don't need a browser for that. You don't need anything else. You just really, you don't need to debug it once you've got it running and it's working. So as I hit start, I'm now loading everything, right? So my ng serve It's all ready to go. I didn't have to type it. I didn't have to do anything. It's configured. .NET Core with Visual Studio gives you that option, that ability to do that. My web API is there. Everything's there. And in terms of my authorization server, it's running there as a separate process. So now I get the best of both worlds. I have my debugger here on the server side, and I can step through stuff and respond to requests, hit breakpoints and all that. But then on the client, I can go and save files and do everything I normally do as the client. So hopefully that kind of helps with your workflow and getting things set up if you are full stack. That's the way that I found is most helpful in terms of flow. Authentication. We don't have a lot of time to talk about authentication because I want to get to other topics, but the idea is this quote couldn't be more true. The thing with security, a lot of things will work. There's so many different ways to do authentication, but most of them are not a good idea. Stupid, simple, and working doesn't cut it. There is a fantastic Pluralsight course by Kevin Dockix, I think I have the link there, that really talks about all of theth concepts of OAuth 2, OpenID Connect, and everything else, and setting up your identity server to do everything out of the box. What's nice, and it talks about the different flows. Now, you can probably guess, with a client application like SPA, it's one of the most dangerous, wild, wild west ways of doing authentication because it is a SPA. That means that you have it's very disconnected. You go out, and we're doing token-based authentication. We go out and we get a token, or we get the token from the authentication server. We have an ID token and an access token. I wish we could talk about these in more detail, but we don't have time. But the basic idea is, once you have that token, however long that lasts, great, you're authorized. You can go and click around and do everything else. You have route guards and other stuff, but that's all client-side. We need server-side restrictions as well. We'll talk about that in our authorization section shortly, which means you have to do the implicit flow. Because this is a public client, we can't trust the client to store our credentials and all that stuff. And the tokens have to be short-lived. Because if that token's ever tampered with or stolen, whatever happens to that token, if you have a day or 2 or 3 on your token lifetime, once that token's there, they are authenticated as though they are you. So you've got to really, my tokens are 5 minutes on this app. Now, there's the problem of you don't want to have to require the user to log in again every 5 minutes. You want some form of process that's seamless. As long as they're making API requests and their sessions active, you want to be able to do some silent renewing as well. And we won't go into too much detail now, but that's the best option you have for the best UX in terms of staying authenticated. So OAuth 2 and OIDC. Basically, we had this OAuth 2. It was great, but it was missing a lot of things. OAuth 2 was great for authorization, but for authentication, we use OIDC, or OpenAD Connect, and the idea is it runs on top of OAuth 2. OAuth 2 is kind of the standard. It's actually a protocol. And then we say we have a more complete security solution now as a result of doing that. Identity Server 4 is, I think, the latest version. This is a .NET Core implementation of OIDC, OAuth 2. It is your one-stop shop for authorization for authentication if you need to do your own centralized authentication on the server side. So the best starting point for all of this, they have a UI quick start that gives you literally like 95% of the way there of logging in and managing users, registering all that. But for me, I just use Google. You can any OAuth 2 provider, you go to their site, you register your app with them with Google. It was very straightforward. And you say, then you configure Identity Server 4 through configuration, not as much through code, but more through configuration in the code, if that makes sense. You say, I want to only use authentication. I want to use external authentication. I don't want to manage the user. I just want to say, you're authenticated with Google? Great. Give me your email address, which will be in that token, and now I can look you up in the database, and on the application level, the business level, I can start to say, okay, I trust you are who you say you are. Now we'll work on the authorizations or the authorization side of things. So we don't have time to go over the auth on the client, but just really quick here, the idea is your config here, this is the key. Most things stay the same across apps, but you provide it with your endpoints. So you say, you name your API and saying this is the scope. You have to have These are the things that I am allowing access to. You have your ID token, all that. Again, local storage on the client, we're going to store the token there. Not the best idea for a lot of situations, but for now this works for our purposes. But in general, local storage is not so secure. You don't want your access tokens there. There's a whole big article on that. But it's a starting point to at least get things up and running. And then you can implement your own web storage state store, your own user store. It's configurable because it's just an interface to manage the retrieval and the expiration, all that, of your token. Like I mentioned before, automatic silent renew. You have a redirect URL that you hit that will automatically refresh that token behind the scenes, assuming you're still your session's still active. The authority, that would be the endpoint of the identity server in your solution. So in terms of the server side, setup's pretty straightforward. The only things that, the only things that I really had to change, I marked here, is adding, I just newed up a test user store because I don't want identity server to manage users for me. I just want to take whatever comes in from that that external authentication, which makes things a little easier. So I had to do a few things to get that to work. Again, I can make all of this code available if you need it to kind of get a starting point, some boilerplate up. But this is where it becomes, this is basically the few lines of code that you need to set up that external authentication. You just say, hey, add Google. Again, this is your startup CS, just like your regular .NET Core service injection. You're saying, here's my client ID, my client secret, which I've thrown into a config file. I get that from Google, right, as I register my app, and that's all you need. You know, you can add other ones if you want OpenID itself to manage a lot of the authentication, or sorry, the authorization, but that's basically it. You don't have to do a whole lot more than that. In your configure, that's where these are where your settings are going. Okay, how do we manage what type of token are we using? It's most likely going to be a JWT or a JOT token. What's the lifetime? Again, it's, I'd say, 5 minutes. And then importantly, what are the scopes? What are the allowed scopes in all of this? And all this stuff gets digitally signed. So in terms of tampering and stuff like that, it's a very secure way of handling it because of that digital signature that Identity Server 4 gives you out of the box. Okay, really fast. We're running short on time. We've got a couple more concepts here. Policy-based authorization. If you've probably been used to role-based authorization on the server. Okay, authentication, great. We know who you are. Now what can you do? This concept of authentication versus authorization. They're two very different things. So we have three parts. We have a policy, we have a requirement, and we have a handler. The policy is kind of the starting point. You got one or more requirements, and then each of those requirements can have one or more handlers. And I prefer policies over role-based authorization for a lot of reasons. They're very expressive. You can get very granular. You can inject services, maybe do some database calls to check some authorization stuff. They're reusable and they're testable. Your role-based stuff, it's a little bit less straightforward to that. But role-based works great for very simple scenarios. But for me, I like to use the policy-based. So what you do in your startup, you say, okay, here's the name. You just give a unique name to the policy. I like to use verbs to make it human readable, human friendly. Say, okay, can you edit this? Then I say, okay, here's the requirements for that policy. New up the requirement. The actual requirement itself just is a marker interface, which means it's empty, right? We just use that to mark it so that .NET Core is aware of it. And then the magic happens in the handler. So the handler you have, here's the name of my handler, the handler, and then you pass in the type of the requirement. And this is where you do anything you want to say whether or not this passes or fails, basically. So you do a context.succeed or context, I'm not familiar with the API, but basically here is where you do all of your logic. And you could have this go out to a service, which I did in the case I have a role service on the back end, because it's not as simple as are you in this role, are you in this role. There are certain other things that I wanted to abstract away, such as the ability to do ors or ands. You know, that logic can sometimes get tricky, and it's nice to have that encapsulated in a function that just tells me those things. And you have access to your database, you know. So a lot of rich set of features in policy-based authorization. It's the way to go. It's the direction that Microsoft's going. I highly recommend it. And then to use it, Similar to your authorize attribute that you throw on your controller method, pass in the name of the policy and you're ready to go. Okay? Domain-centric design. All right, I'm down to 10 minutes. We're going to try to blow through these last couple topics here. I'm sorry, we will probably not get to Azure. I wanted to quickly show how to set up your CI/CD pipeline, but we won't have time for that, but I have some great resources for you on that. We have kind of this evolution, you know, back in the good old days, and even now I see a lot of this database-centric, N-tier, sometimes even 2-tier, you know, monolithic. It's more data-driven, right? The database is the heart of it. And yeah, the database is the heart of your system because it's data, right? You can't have an application without data. But in terms of your design, the architecture of how you're constructing everything, it's not the most important thing. It's what we call an implementation detail that we can abstract out of the project, so to speak. So we kind of said, okay, let's do separation concerns. We have nice components here. We have MVC. Okay, we're getting there, right? We're service-oriented. Sweet. Well, that kind of breaks down too because it's just not, it's for many reasons. But then we finally get to this concept of, okay, we are domain-centric. The domain, the business layer, more of a common language, a common location to do our things, to make things very testable and very separated and isolated from the details. The details being your database and your UI, your web client in this case, right? We have microservices and everything else. This is kind of what we're striving for. And anyone who's done enterprise application development with tons and tons of stuff that are very complicated, you come to appreciate these things over these things. You come to realize that your classic N-tier breaks down pretty quick. Again, the first concern of the architect, make sure the house is usable. Don't worry whether the house is made of brick or not. What's essential, what's your domain, versus what's the implementation detail. So this kind of illustrates the concept. This is what I, in my career, are more familiar with and what a lot of people are as well, I think. You have your UI that talks to your business logic talks to your database, and then it passes back up the other way. And anyone who's done a lot of DDD, domain-driven design, or TDD, realizes that this breaks down pretty quickly because it's harder to unit test, and not having those layers completely separate, because the UI knows about the business layer knows about the data access layer. So trying to go up and down that chain, you're going to mix concerns, and it's going to be harder to maintain over time. So the idea with domain-centric design, again, the devil's in the details. There's lots of different ways to do domain-centric design, but the basic idea, and we'll show you here, is that you have a presentation layer and an application layer, but your persistence, your database, and any other infrastructure things, and again, your UI layer is all on the outside. Your domain is the centerpiece of that, right? So what that means is, here's the rules in order to do it. The domain project, okay, so when we talk about the data project, we're talking about the database. This is your entity framework, your raw POCO objects that are mapped one-to-one to the database tables. You have your domain layer, which is your business logic, and your domain will show has no external dependencies. Granted, there may be some core framework dependencies or some extension methods, but the idea is it's not, the domain knows nothing about the data layer, and it knows nothing about the client layer. So, no external references. Rule number 2, both data and web reference the domain project. The data, and the final rule, the data does not reference the web project, and the web does not reference the data. There is a huge exception to this rule. I'll show you in a second. And that is this. I guess I'm on it now. What about your dependencies? So your client, your web class, your startup CS, you've got to map the interfaces somewhere, right? You've got to say, okay, this interface in my domain layer maps to this service in my data layer, because you have to implement a way to get and save your data. So what you end up doing in your startup class here, sorry, we're down to like 5 minutes, I'm hurrying. What you do in your startup class here, if I can get on the right one, this one, right? If you notice, each of these point, I have to probably stop the app here. You know, iProfile service, that's going to be in my data, my domain layer, but the profile service itself is implemented in the data layer. So how do we get around this? Because if you notice, when I look at the references, it's all about the references to kind of double check your work. So when I look at these dependencies, I say, okay, what projects am I dependent on? So in my data project, I only care about extension methods. Again, that's just your utility classes, right? I point to the domain. Okay. In my domain project, I point to nothing. Okay. That is how you know that you've done it right. There are no external dependencies in the domain. Your objects, your domain objects, are going to be the source of all your business logic on the server side, and they're going to have a bunch of services. These should probably be called data service or something like that. A bunch of interfaces that say, here's your CRUD operations, create, read, update, delete, that get implemented in the data layer. So in there, we have the services that actually implement those interfaces in the domain. But now we go to the web API, and we look at the dependencies, and we say, okay, well, based off what you've told me, that means we shouldn't be pointing. We should only point to the domain layer from the web and external the extension methods. Again, this your utility. But now I have a reference to data. That's bad, right? My UI layer is pointing to my data project, but I have to map those dependencies. So this is a problem that developers kind of struggle with in saying, now my data layer is leaking into my UI layer. What do I do? So there's a couple of options. For one, everything's namespaced, matching the project structure. So if I do a search for this, and I say, okay, where is this referenced? I can search the entire solution, or sorry, just the current project. You'll notice the only place that I'm making that reference is to map my dependencies. So I'm going to say, as a developer, I'm going to say that's acceptable. Yes, it knows about the data layer, but at least it's acceptable that that's the only place that I'm referencing it. And you just kind of have to, through code reviews and making sure everything else, you have to make sure that you're not leaking, you're not referencing the data layer somewhere else. There's another solution. I haven't tried this, but there's a way, granted he had to use a different IOC, a different dependency injection tool, structure map. But there's a way to say, okay, let's just do by convention. So when I see an interface, I'll go say a concrete class is the name of that class without the I in front of it, and I'll do all of that automatically for you. And he actually was able to achieve no references to the data layer from the client layer, from the web API layer. So again, just something to think about as you're trying to do it. So we do have this concept that we need, what about my data transfer objects? You never ever leak your database entity classes anywhere outside of the data layer, right? And consequently, I recommend never leak your domain classes to the client layer. So there has to be that conversion that happens both from entity to domain and domain to entity that happens within the entity, the data layer. And in your client layer, you have to make sure that you're converting between domain and view, what I call view model. And the reason for that is because we want complete separation of concern so that when backend makes a change, they add a database field or they change the name of the database field, we have that strong typing, that mapping in the UI layer so that it doesn't break the client. Otherwise, if you're sending domain objects straight to the client, I'm sure all of you have experienced this, backend breaks front end, and that's bad. That's what we want to avoid. So unfortunately, I'm out of time here. I can't go into details on how that conversion takes place. There's lots of different strategies for doing that. I just have a converter class that goes from one to the other and flips back and forth. But the bottom line is both projects, the data and the UI layer, are referencing that data layer, and that's how you get to where you need to be. Really quick, just one more minute if you could hang out with me here. DB context, where should it live? DB context, we don't have a lot of time to go over it. I wish we did, but the basic concept, if you're not familiar, is entity framework. That is your gateway to the database. It needs to live in the data project because it is a data concern, right? We don't want a DB context in our client layer or in the domain layer. We should never have to reference it. So this is where you map your fields. So I like to suffix my classes in the entity layer, in the data layer with entity. And granted, that's a little confusing with domain-driven design, but since I'm not doing full DDD here, I say, okay, I'm talking about an entity framework entity class. And then in my UI layer, I suffix it with view model, so I can say, okay, when I see a profile class, is it a profile entity, or is it a profile view model, or is it just a profile? If it's just a profile, I know, hey, that's the domain object. That's the universal collapse with the business logic that I'm unit testing against, right? So you do have to map. That's kind of annoying, but you can automate this if you need to, if you have hundreds of tables. But you have to say, okay, this maps to this table in the database. That's fine. But what's nice about these relationships with your data is that you can say in code, there are some things at the database layer, like your relationships, that you don't really want to, don't make as much sense to enforce at the database layer, maybe make more sense at the application layer. Or you just need to enforce it on you need to tell a native framework about those relationships so that your app runs a little smoothly when you're updating and doing stuff with related data. So you have, for example, if I want a 0-to-1 relationship between a table, you can do that through your Fluent API syntax, which is really nice. One last thing, sorry I'm holding you a little bit late here. This connection string, where does it live? If I do a search for this in the entire solution, whoops, it is nowhere. So there's no config file, there's no JSON file. Where does that DB context, how do we know about that? The answer to this is .NET Core is really smart about having a layer that is configurable of where it looks for your config settings. And what's nice is, by default, if it doesn't find it in your local config file, your JSON config file, it will actually start searching up the chain. There's a hierarchy similar to how your web configs were managed. But what's nice about this one is it will actually go to a system environment variable that you've set if you want that layer of security of saying, I want my connection string because I'm cheap and I don't want to have 2 different databases for my local project. I just want one prod database. So I say, I'm not going to throw this into source control. I don't want people to know my connection string. Throw it in that system environment variable, it'll pick it up. And because it's optimized for cloud, when you go up to Azure, those settings are all on the cloud in your Azure portal. And unfortunately, we don't have time to go over Azure stuff. I wish we did, but before you go, I did want to show setting up a CI/CD pipeline is so easy. There's templates for it. You point your source code to it, and it took me about an hour total for my site, not even thinking about cloud, to getting it up on an app in Azure, hosting my data in SQL Server on Azure, having my website hosted in Azure. It was so nice, and there's so many tutorials out there. Really, just a quick shout out to the Salt Lake Azure group, SLAG. We meet on the second Tuesday, I think, of every month. Is that right? So if you want to learn, we do everything from beginning to advanced topics. It's a really good resource. Also, it's called the 9 Nights of Azure, I think, getting started. Azure is so huge. It's this bridge between DevOps and development, and there's lots to learn. So if you want kind of a getting started point, there's these 9 nights, they call it, whether it be an app service or SQL Server or data storage solutions, all that kind of goes over that. Some great Pluralsight courses. There are so many paths in terms of where you are. Are you a developer? Are you an IT guy? How do you want to learn Azure? How do you want to approach it? What do you need it for? Pluralsight's one of the best resources for that. And then, of course, STG, if you're an STG employee, and on an as-needed basis, we can make it, if we need to make it work. We have STG branded certifications that are peer-reviewed, and one of those certifications is Azure. So if that's something you're interested in, if you're an STG employee, great, we can get you started. If you're not, we can still have a conversation, maybe start you on one of those as well. Again, I highly recommend Azure. I don't have to be a sysadmin. I don't have to be a DBA. I don't have to be all those. I don't have to wear all these hats. I just want to write my code and have it run in production, right? And Azure is in my opinion, compared to AWS, I know I'm partial because I'm a .NET guy, but is by far the easiest way to do that. I'm so sorry we don't have time for questions, but thank you so much for attending and for coming, and best of luck to you.